Welcome to the A4Q Global Testing Summit. We are in the middle of an exciting day full of insights and discussions from the most experienced software testing experts. I'm delighted to now welcome Lovelesh Beeharry. He's the founder and president of the MSTQB, the Mauritian Software Testing Qualifications Board. With more than 11 years of experience, he's a leading expert in the field of manual automation, performance, and security testing. As a team leader at IKERA, he managed several automation test engineers. As an ISTQB trainer, he also coaches students and professionals to achieve their ISTQB certification. At the end, you have the opportunities to ask questions, so feel free to hit the comment section. And now I would say have fun, and the stage is yours.
Thank you. Thank you, everyone, for tuning in. Today we have an exciting topic actually to talk about. So that would be the mathematics of performance testing. And this is a topic I chose because we tend to forget the mathematical concept when we do performance tests, when we do analysis. And this will give you an insight, I hope, that would be able to help you in your day-to-day work when doing performance test. So thank you for the introduction. So I am Lovelesh Beeharry. I'm leading a team of software test engineers specialized in automation performance testing at IKERA. I have around 11 years of experience in software testing in the quality industry. I've been working for quite different companies, and I'm specialized in manual automation performance and starting on security as well, security and AI. That's my new focus now. And I'm the founder and the president of MSTQB, Mauritian Software Testing Qualification Board, which is the Mauritian chapter for ISTQB. And in my spare time, I'm a coach, software testing coach. I also deliver conferences like this one, and also I train newbies on ISTQB. So let's get started. The agenda for our discussion today would be an overview of performance test. Then we'll dive into user journey and some concept of random number generator and how it's used in performance testing, and some statistical concept about performance test result analysis. Then we have the calculus, the performance and calculus, and it's linked to performance testing, and the best practices, things that I've learned the hard way or things that I came to know when I was doing performance testing based on research and so on. And we'll end with a session of questions and answers. So let's dive into it. Performance testing. So to give an overview about performance testing, it's quite challenging because we have quite some classification about software testing in terms of performance. But the three main broad categories would be load testing, stress testing, and volume testing. So load testing is about increasing the number of users over a certain period of time to an expected load. Let's say we are having an e-commerce website, and we are expecting like 500 users to use the software. So that's the expected load, okay? And we'll increase the number of users to that amount of load of users so that we can judge whether the software is working correctly, it's stable, and so on. And the objective at the end is to confirm whether we have met the SLA, the service level agreement. Let's say we have a certain transaction that the user do on a certain software, e-commerce again, let's say purchase, and that's supposed to be done like within 30 seconds, and that's an SLA. And when we do those load tests, we'll make sure that we are able to abide to those SLA. Then the second classification of performance tests is stress testing. This is about strategies to test surge in terms of users, or to test a certain constant number of users over a long period of time, more than expected. For example, again, let's say we have users who are using the software for around 2 hours a day. And with stress testing, you will keep that number of users constant, but you will test it like for 12 hours. And we see whether the software is still stable over that period of time or not. And also, we can inject certain surges of users on the software platform. This is quite practical actually in sense. For e-commerce website, we've seen that when we have surges, software breaks, and those surges are actually happening at the end of the year. Like let's say for Black Friday, we have more users connecting to a certain platform, and that's actually breaking the system. So to prevent that, this is where we'll have to define the stress testing strategy quite well. And the objective of doing it is to confirm again if the platform is stable over a long period of time or with surges of users. And the last classification under performance, this is volume testing. So this quantifies, for example, response time when users are actually constant, but the data actually in the system is increasing. For example, again, for a shopping platform, e-commerce website, we have around, let's say, 1,000 products, and we are getting a certain response time. What would be the response time? What would be the user experience when there is 10,000 products on it or 100,000 products? So this is part of volume testing. And the objective is, again, to confirm whether the platform is stable when we increase the data on the system. So those are the classification about performance testing. Now, let's get into detail about the user journey. Why we need to have a user journey performance test? Well, the basic concept is to do performance tests, which is as close as possible to reality. The aim is not to have like we're expecting 500 users on a certain software, on a certain online system. The aim is not to test like, can all the 500 users log in at the same time, clicking on the button at the same time? That's not the aim of doing performance tests. The aim is to ensure that the system is sustainable or is stable with 500 users doing transactions that may be different from each other. For example, there might be a user who is trying to log in, who is doing a purchase, another one who is just searching for product, another one who is just adding product to cart, and so on. So those journey, they are intuitively, or they are by nature different to each other. So that's why we need to actually come forward with a user journey which is different. So how do we do those user journey? How do we design those user journey? The first step is actually to break the user actions into transactions. So each action that can be performed by a user is a transaction in the performance test. For example, login, making a payment, or requesting a refund. Those are possibilities for the user actually to do on the system, and those will be transaction on performance tests. And we have to script those transactions then. Then the user journey is to how to connect those transactions together and making a flow out of it. For example, again, login, search, then you can do a search again, another search, and then purchase a product and then log out. So there are some transactions that can be repeated over time. And this is what makes each user journey distinct to each other. And then once these are already done, the aim behind is the global aim is to have different user journey for each CVU. A CVU is a concurrent virtual user. So it's a virtual user that we are injecting on the system to get the data out, to get the response time, the user experience, and so on out. So each concurrent virtual user will have a different journey in this mechanism. So now we need a mechanism to find how to define those journey. So how do we go about it? The first one is, well, to make it as close as reality is, we need to take sample from the production environment. We need to have those data first. We need to understand what our client are doing on the system. We need to understand the real user journey, what actions they are doing more than the others. For example, login is certainly the action that would be done by everyone. And doing a purchase is something optional. But looking around for products is something more than doing a purchase. The probability of a user doing searching for products is higher than doing a purchase or removing from cart, something like that. So we need to take a sample of users from production and analyze those transactions in depth. And what's the result of those analyses? Is to have a certain model, a user journey model. We need to build a model on the user journey in a probabilistic approach. And what do I mean by probabilistic approach? So it's about defining the next step of the user. So after user login, what's the probability that he will he will be doing a purchase? What's the probability that he will be adding something to cart or searching for a product? So once we have those probability defined, we can model the user journey. And once we have the model, then we cross-check it with the definition, the service level agreement. So some company do have it, some company don't. This is again based on the user experience. For example, a website for marketing will have SLA. Like when you're doing a search, you're expected to get a certain result in this amount of time. Most companies do not have those kind of SLA. So this is a step that actually will help to define whether a performance test is passing or failing. But if we don't have it, then we'll have to do another type of analysis, which is known as percentile analysis, to define the SLA and whether it's agreeable to everyone to move forward with that SLA or not. And the fourth step is to use random number generator. Well, this is the easiest way actually to model a probabilistic approach towards real user journey, is to use weighted probability approach. So random number can be very handy actually to do that, because we can specify the range of numbers where we want the software to generate a certain, or test framework, the performance test framework, to generate a random number, and use that random number to define the user journey or the user itself. And then once these are done, we need to run the test to ensure that we are complying to the model. So the aim is we make a model. Out of the model, we constitute the user journey, and we test that user journey based on the model. So we have to make sure that it's properly coded. The test framework is properly coded. And this is where we test the implementation. Once these are done, we have a working version of the test framework, and then we can move forward with the performance test. Well, we are talking about random number generator. So the concept is to have a mathematical formula behind. Those formula actually doesn't need to be coded as such in the program, because we have it already as libraries or as innate functions in different programming languages. So once we have that random number formula there, we just run that formula, and each time it is solved, it is generating a different random number. And we can have it bounded, right, to generate a random number between 0 and 100 that will represent a certain percentage, and that percentage corresponds to a certain probability. And the random number can be used to mimic the probability for each transaction. Well, all these sound a bit confusing, so let's dive into a certain example that will clarify these. Again, the simplest one is actually to take an online shopping platform. So let's say the online shopping platform had different user roles. The first one is being an admin, and the second one a buyer who is listing their product to be sold on that platform, and a buyer who will be buying the product, and a seller who will be listing the product on the platform. And each of those user roles will have a different transaction, will have different possibilities of doing. For example, an admin will have login, approve, seller listing, reject the seller listing, and so on. A buyer will be able to search for a product, to open the product listing, to add to cart, to remove to cart, request a refund, do a purchase, and so on. And a seller would be able to post a listing, will be able to accept a certain refund request or refuse it, and so on. So those are the user transactions. Now, when we see the population of the users who are using the online shopping platform, we need to find a certain model of it, and that's the weighted probability. So we say 10% of our users are admins, 20% would be sellers, and most of them, 70%, would be buyers. So this is where we are starting to constitute the model. And now each transaction that those users would be doing would have a certain probability weight as well. For example, a buyer would be most likely to do search for a product. So you can see that it's 30% of the transaction over here for the users is corresponding to search for a product, and they will be least likely to remove a product from a cart. So that corresponds to 7%. And even logout as well, we need to consider logout, because not all users log out, they just close the browser. So that's also an important information for us to have. Like we can say that most 50% of the buyers would be just closing the platform, and this is part of the model as well. So Now, we have the first random number generator that would generate a number between 0 and 100. Okay, based on that number generated, if it is falling like between 0 and 10, which correspond to 10% of the admin, that user would be onboarded as an admin. If it is between 10 and 80, which is correspond to 70% of probability, that user would be a buyer. And if it is above 80, that would be a seller. So that's the first random number generator. Now, once we know the user role, the second random number generator would select the transaction itself. So if it is a number generated, let's say between 0 and 30, that would be 30%, and that would be like search for a product. And the last one is the third random number generator is to define how many times that transaction will be looped over. For example, a user can search a product, can do another search for a product, another search for a product, and so on. So we have loop weights, which is the third column over here. We have loop weights, and a random number will be generated between those two bounds, between, let's say, for search a product would be 10 to 25. A random number will be generated for the third one, a random number generator, and that would define how many times that transaction will be looped over. So let's apply it now. So the free random number generator, and in the first one, let's say the random number that was generated is 46. So given that 46 is between 10 and 80, a buyer will be onboarded. So the number generated that correspond to a certain probability given the range of the lower bound and upper bound that we are having. So once it is generated, we can say whether it will be onboarded as a buyer, an admin, or a seller. Now we move to the second one. Another random number was generated, which is 32, and 32 is within the range of 30 to 50, and that would correspond to a certain transaction. In this case, it's open product listing. Okay, and the third random number generator is 15. That was between 10 and 25. So it means that the open product listing would be executed 15 times. Okay, so in the whole, we get a user journey like this. Client is login, or a buyer is login, and then they are executing product listing 15 times. So we get a user journey like this. And this actually corresponds to a certain chart that we can constitute with the user journey, with the buyer roles, and the transaction that each one will do. So each user has a different journey. Each journey is based on a transaction probability model, and the user journey are meant to be as close as possible to the real situation on production. So this is how we can use random number generator and probability to simulate real user journey on our test, on our performance test. Right. Now, let's talk about the results. Once we do the test, we are able now to simulate user journey, and we are now able to run those tests. Once we get the result, we need to analyze those results, because the end product, the end of performance test is about whether we are meeting the SLA, and if we are not, what should we do? What should we optimize? Where we should concentrate the code optimization effort to actually meet the SLA. So there are different ways of actually reaching to those points, but the most used concept for statistics on result analysis is the measure of central tendency and the measure of dispersion. Okay, the measure of central tendency, we all know about average. It's the sum of all the let's take response time, for example. It's the sum of all the response time divided by how many items we have in the sample. But we tend to forget about the other measure of central tendency. We have mean, mode, median. So median and mode as well could be used for those result analysis. And why would we use median and mode? Because some of the performance tests, I've seen that in many of the tests that I've done, we have outliers in the result. What do I mean by outliers? Those are extreme information, let's say extreme result in terms of response time. Let's say we have a transaction that is taking 2 seconds for like 10 users, and the 11th one is like 100 seconds. Okay, so the average over here would be 10 plus 100. 100 is the outlier, and then we'll divide by 2, we'll get 55, which is outside the range for the 10 users. And this is why mean is a good measure, but it needs to be complemented with the other measure of central tendency, just to make sure that they are conform to each other. If we have a mean which is very high, it means that there are many outliers compared to a median. So a median and a mode is less susceptible to be impacted by outliers. That's about the measure of central tendency. And now the measure of dispersion. So dispersion, the measure of dispersion is about the spread of the data. Again, we have, let's say, 10 users doing a certain transaction in 10 seconds, and the 11th user is doing it in over 100 seconds. So we have a spread between 10, less than 10, or let's say 0 to 100. Now I onboard another user and it's taking 1,000 seconds. So we have a spread between 0 and 1,000. So the range or the dispersion of that data is quite high compared to the first 10 users. And how do we measure it? It's through the measure of dispersion, which is range. Range is simply the maximum minus minimum, the maximum response time, for instance, minus the minimum one, and the variance. We have a complex formula for variance, but it's a good measure for the dispersion of the data. Problem is the variance give you in, let's say we are measuring response time in second. The unit of variance is second squared then. And we need something that will be comparable to the information we have, the response time in this case. So then we use standard deviation, because standard deviation is just under root variance, which is in seconds. So it is in same unit as the dispersion of data that we are trying to measure. So the average response time, it's important. The median as well, to confirm whether the average is conform to the data that we are getting, and the throughput. So when we talk about performance tests, the first thing that comes to mind is the time that's taking. Initially, the primitive way of doing performance tests is everyone getting a stopwatch and doing the same action at the same time, and then starting and stopping the stopwatch. Now we have tools for that, and we can use those tools actually to a higher level, to a more advanced level, to measure the throughput as well. So the throughput is the number of transactions being processed per unit time. So what does it mean? It means we are trying to see how many requests are being generated by those users we are trying to onboard onto the system, and see whether our system or our services that are behind are able to handle those requests. And we have the response, the extreme response time, which is the minimum and the maximum. That also can give a good picture of whether we have a good dispersion of data or we have an extreme dispersion of data. And the standard deviation is just to measure the spread of the response time, or the throughput, the CPU usage, memory usage as well, across our test. So those are some statistical concepts that are very much applicable to performance testing. Those are some results. Those are some real life results actually that some of my tests we got through some of my tests that I've done. So I've analyzed the mean response time in terms of milliseconds. We can see that through the graph, as I am increasing the number of users, it's quite stable. So it's a nearly quasi straight line. And then we have the measure of dispersion, which is a standard deviation in terms of millisecond. As I'm increasing from 25 to 200, it's more or less stable, but it's getting unstable. There is a peak when I'm increasing from 200 to 400. So what does it mean now? When I have a certain increase in the chart like that, so it means that the data is more spread. What it means? It also means that the user experience will vary from user to user. So one user will be able to get a certain response time which is reasonable to him, and others would be actually waiting a lot. Okay, so this is the value that the measure of dispersion brings to the analysis, and standard deviation is a good measure of it. And the extreme and response time analysis, this gives you the red is the maximum, the blue is the minimum. This gives you a comparison of the user experience. You can see again for 400, the red column is very much high compared to the minimum response time. So those would be the extreme, the minimum and maximum comparison. And the throughput is the request that we are sending per unit time. It can be per minute over here. So normally the throughput is expected to increase linearly, or not necessarily linearly, but increase over when we have CVUs increasing. So more requests will be sent. If we have a certain exponential increase, that would mean that we need to optimize. We need to optimize certain part of the system, of the transaction. So these charts are per transaction. We can take login, for example. When we have 400 users login, so the throughput is higher. And if we see that there is a trend of exponential increase, then it means that login as a transaction need to be optimized. Right. Now coming back to the part where we didn't have the SLA. Let's say that was step 3 in the previous slide. So if we don't have the SLA, then we need to apply the concept of percentile analysis. What does it mean? So we have the CVUs, the concurrent virtual users, over the response time, and we see a certain trend. That's this chart is known as this trend actually is known as the cumulative frequency curve, and we can do percentile analysis on it. We can say 50 percentile of our user, or 50% of our user would be having a certain response time which is less than 30 seconds, and 75% of our users will have a response time which is less than 34 seconds. So those response time actually can be used to define the SLA or to confirm the SLA as well. The aim is not to have 100% of the users below a certain time. Why? Because the response time can vary because of different part of the system. There is the architecture, there is the software code itself, there is also the hardware, the user hardware. Let's say someone is trying to access the shopping portal from an outdated hardware. Let's say it's an old mobile, still a smart mobile phone, but it's an old version of the operating system, and the machine the mobile phone doesn't have enough memory and so on, but still the user is trying to access it. So that will that will actually cause an outlier in the result, in the test result. And this is the reason why we don't actually in reality target 100% of the users having a certain response time, but rather 95% or 90% of the users below a certain response time. And this helps, this percentile analysis helps to define the optimization needs as well, because each transaction have a certain priority. Let's say there is a transaction which is less used by the user. The code optimization need for that would be of lower priority because there are higher ones that need to be tackled first. So the percentile analysis as well helps to define the optimization need on the long term. Right. Now coming back to the mathematical concept of calculus. Right. So there are many tools that gives you a chart. There are many tools that give you chart, and those charts are actually having a trend in it. In this case, let's say it's CVU versus average response time. So, oops, sorry. Yeah, so we have response time in second, and we have the CVUs in the x-axis, and we have a certain trend like this. So what this chart can help us to understand is that the response time is not linearly increasing. It's not increasing linearly. It's a polynomial chart. It means that there are some sporadic increase. It's not like following a defined trend like linear or exponential, but there is some sporadic increase. And when you have these kind of chart to analyze, it's not only the increase that matters, but the rate of increase as well. And the rate of increase is the first derivative of the equation. So how do you get the equation of these kind of chart? You can have like simple tools like Excel actually can give it to you. So you just need to import those data onto a spreadsheet, and then you draw a trend line, and the trend line would actually have a certain equation, and you can use that equation to find points where you would like to know the rate of increase. And the rate of increase is the gradient of the tangent at that curve, at that point in the CVU on the curve. So the rate of increase of response time is the gradient, and it's given by the first derivative of the graph function. So if we have f of x is the graph, and so the first derivative will be f dash of x, would be dy by dx of the curve, and then that equation will give you the gradient. And why it's important to find the gradient? Well, this chart actually helps us to understand where to concentrate the stress test, because when you're doing load tests, the next step is to do some stress testing on the software, and to know where to do those stress testing, you need to find places where the system is susceptible to be down or to go down because of surges. So where do you find the surges? Is where first there is the gradient is 0, the tangent is 0, so that's the first derivative, and you have the possibility of having a maxima and a minima as well. So when you have a parabolic curve, so the minima is where you would first concentrate on stress testing, and the maxima as well when you first concentrate on the stress testing. And the maxima and the minima is given by the second derivative of the equation. And again, if it is f dash dash x equal to 0, this is where you will get the minima and the maxima. And you can concentrate on those stress testing at those points, and this will give you whether the system is susceptible to go down after you inject a certain surge at that point. Yeah, and over here we are using average response time, but we should do the same analysis with CPU, with memory usage, and the throughput. This will be more complete, actually, in terms of performance test. Right, and one of the questions that I get quite often when I explain these concepts to candidates for training and so on, so is the question is, why do we have those haphazard or sporadic trend in performance testing? Those are mostly because of the time complexity. So it's a concept of big O notation. So when we have a certain code, it's taking constant time, that's O of 1. It's a constant time complexity. When it's linearly increasing, that's O of n, big O of n. And codes that actually do looping on a certain array to add those items together, those would be following a certain linear time complexity. But we have more complex code that does a quadratic time complexity. That's big O of n to the power of 2. Those happens when you do nested loop. Those happens when you do bubble sort algorithm. There is a lot of algorithms that actually have those kind of time complexity, the quadratic time complexity. Logarithmic time complexity is big O of log n, which happens when you do recursion, when you have recursion in your program. And quasi-linear is big O of n log n. This happens when you use heap sort, when you use merge sort algorithm. And exponential time complexity is 2 power n. That happens when you do Fibonacci sequence, where you have functions that actually are doing the Fibonacci number generator and so on. So that would be exponential time complexity. And we have the factorial. The factorial time complexity, which is O n of exclamation, which happens when you have looped recursion. For example, when you do shortest path algorithm, that's the factorial time complexity. Because a software can have different construct, okay? They have different combination of construct in the functions, in the user action. We have those sporadic performance result. So we have basically 4 construct in programming. We have the sequence, codes following each other. We have selection, like the if construct, case construct, where we select a certain part of the code. And then we have the iteration, which does looping, the for, the do while, the repeat until. Those are iteration construct. And the last one is recursion. So a function calling itself is recursion. So when we combine those constructs together, a system becomes quite complex to judge whether it's taking a lot of time, whether it's good or not, or it's according to the SLA. And this is why performance tests need to be carried out. And having those mathematical concept in mind when you do performance tests helps actually to drill down, to come forward to actually find the root cause. It helps a lot to find the root cause where code optimization effort need to be focused on. So those are the time complexity. Big O notation is only part of it. There are other notations that are used, like omega and so on, that are used for measuring time complexity. Right. Now, leaving behind the mathematical concept, now let's get into how those concepts actually help us to define the best practice and the lessons learned from test performance framework. So we've learned that different user journey should be as close as possible to the reality. That's very important. The aim is not to have all the users doing the same transaction at the same time, because that is very unlikely to happen in real life. And we have to conduct the performance test with sleep time and without sleep time. Well, what does it mean? Let's say we have a user who is trying to register on a login on a certain platform. He's registering over there. They will take time to enter those details on the system, and those time will be simulated on the performance framework with a sleep time. So we have to do the test with sleep time and without sleep time. So with sleep time will be load testing with expected load on the system, and without sleep time it can be like a stress testing. We have to monitor more than the response time for transaction. I've seen many performance testers whose focus is only on response time, but that's part of it. Response time is important because it defines the user experience, but we have other things like throughput, like the CPU usage on the server, the memory usage. Those are equally important as well. So we have to keep in mind that those parameters or those factors are as well monitored. Then we have to use an APM. Well, that's recommended to use an APM tool, an application performance monitoring tool, because when you do performance tests, you get the result from an outer perspective. Now you have to drill into the system to know which call, which function, which line of code is doing that glitch in terms of performance. So this is where the application performance monitoring tool will help. We have different application performance monitoring tools on the market. We have like Dynatrace, we have Fusion Reactor that can help to drill down. And it should be, those APM tools should be complemented with the results we have on the test performance framework. Load tests, not to include only ramp-up scenarios. So when we talk about load test, we think only that we should increase the number of users, and that should be okay. Well, there are other scenarios that we should concentrate, because I've seen as well from some practical example, when we have a ramp up, we have a certain stabilization. We see that there is bad memory management in the stabilization. So the stabilization is also very important to sustain. We have the ramp up, stabilization, and the ramp down. The ramp down is important, equally important, because it gives you other kinds of bugs. For example, I was able to ramp up to 500 users, keep it stable, and then when I'm ramping down, I see that the memory usage is not decreasing. So there is bad memory management over there. So that might be an issue with the garbage collector on the server. That can be an issue with releasing those memory use when it's outdated, and so on. So those are important to keep in mind when you are designing the performance test in terms of ramp up, stabilization, ramp down. And then once we do one cycle of tests or performance tests, it's always a good idea actually to do those tests repeated before a release, so that you can compare the results, the before results and the after results, so that you can see whether optimization really happened, okay? Whether addition of a feature doesn't impact the user experience in terms of response time, whether there is still good management and good memory management or CPU management on the server, and so on. So the before-after test is always helpful to have, and it brings value. And above all, we also need to ensure that the probability model that we created in the first place is still up to date. So when we are adding new features, it means that we are injecting new user actions, new possible user action for the system, on the system, and user would be tempted to use those. For example, we could tomorrow on our online shopping platform, we could include like campaigns, okay? And some percentage of the user will move towards campaign compared to the other user actions or transactions. So we need to revisit those probability model to make sure that it's always relevant to what's there on production. So those are the best practices and lessons learned on performance tests. I've learned few of them in the hard way, but hopefully these can help you on your performance test journey. Right, and that was it. So if you have any questions for me, I would be very glad to answer those for you to clarify.
Okay, great. Thank you, Lovelesh, for
You're welcome.
great presentation. We indeed have some comments and questions.
Sure.
I would start with the first question from our community. And it is, what kind of defect would performance test find?
Right. So the kind of defect that performance test would find is like risk. The first thing is risk about where the system can go down, at how many users actually the system can go down, and also what part of the user action or what part of the transaction is actually causing more. Let's say one transaction when you're doing login is using more resources on the server, which is blocking other users. So those would be the kind of defects that you find. Those would be non-functional defect for sure, but those impact the user experience. And if you have a bad user experience on the software, you will definitely use client down the line. So the kind of defects that I would expect performance tests to find is first some security related. If you are able to take down the software down by injecting load on it, that's a risk for the software. And also a bad resource management and code optimization for sure. That's the primary aim of performance tests.
Thank you so much for your answer. We have a second question.
Sure.
And that is, are performance tests to be done in the back end or in the front end side?
Well, yeah. So when we're talking about the backend performance test or load test, it means that we are invoking those API, the application performance, the application programming interface. So we're invoking those API and testing those API. So there are two ways. There are actually different stages, I would say, different stages where those are processed. So there is the backend that gives the user the response, the data that need to be presented on the browser or on the system. Then there is the rendering side. So performance tests need to be done on both levels. So there is the API level that we could use like tools like JMeter that could do unit API tests, and then we could use different other tools like WebLoad, LoadRunner, and so on to do transaction tests at API level. And we could also couple for the front end, we could use Selenium. We could use Selenium to onboard virtual users that does rendering on the front end level, and that gives the complete user experience, the rendering side and the backend as well. But we have to be careful when doing those tests, those front end tests using Selenium, because the aim is to test the system, is not to test the computer on which you're running the test. So you have to distribute the load evenly on different machines. You might need to have more machines to do those kind of tests, but the aim is to distribute the load on different machines and then to run the test. Yeah.
Thank you so much. We have another comment from the community asking for the tools for performance testing. So what tools do you use for performance testing?
So there are quite some tools on the market. The free one like JMeter, it's very much suitable for testing unit API. You can have one API call and then simulate like 500 users pushing that API, that was a web service, and then getting the response. You see how much time that those calls are taking, how much time you're actually waiting to get the response, and so on. So that would be at API level, at unit API level. And then we have tools like LoadRunner or WebLoad that actually combines those API into a set of API that could run transactions. When I say transactions, it's actually connected APIs together that simulate a certain user action. So login is not only one API, it's multiple API connected together. So WebLoad and LoadRunner are tools that could be used for transactional level load test, while JMeter would be something that you could use for unit API, and Selenium as well. Selenium could be used for the front end performance test to simulate different users as well on different machines. Yeah.
Great, thank you so much. And I think we have a last question. Why would you test a set of API as a transactions instead of an individual API?
All right. So, okay. So the step actually to do performance test, the kind of performance test I'm talking in this presentation happens at the system level. So we are talking about testing the whole system in terms of user transaction, but we need also to test the API at unit test, at the component level. So when there is a development happening at an API level, that API need to be tested by the developers, assisted by the testers for sure, down the line, to ensure that that API is performant enough then to commit it towards the system, to push it towards the system. So we would test unit API at the component level and transactions at the system level. That's the thin line that differentiates both kind of tests. Yeah.
Okay, thank you very much for your presentation. I would say for the community, if you have any further questions, if you have comments, feel free to leave us a comment. Feel free to contact us via LinkedIn, on our social channels. And yeah, thank you so much
Thank you
for your presentation and have a nice day.
Thank you very much.